September 15th. We're here with John Warner, the University of Connecticut, Senior Project Manager, who's handling the Innovative Partnership Building here on the Tech Park Road. John, first building?
First building, Tech Park, yep.
Thanks for taking some time with us today. Give us a little update.
Yep.
Skanska's doing the construction management for you?
Yes, and Skidmore, Owings, and Merrill, SOM are the architects.
Very nice. John, take us over to this rendering drawing here on this fine banner.
Okay.
So this is the view that we're looking at here? This would be to the west.
To the west, this is the street view. We're looking at the lobby areas to the right or to the north side.
And that would that be that tower over there?
It aligns it. I think.
Yeah.
If you look in the back, you can see where the tower is.
Okay.
The better reference is the south tower, which is this piece right here.
It's more of a standalone, John. Right.
It's open.
Yeah. I can see the north tower. It's just integrated in a little bit further.
Yeah.
Yeah.
And then you have the V columns. We'll go down there and look at the caissons that support the V columns.
Yeah.
Which are right here.
Yeah.
Which support the lab bar.
Yeah. I think we'll catch that on some further video. So pretty fascinating. And then what we're looking at there, John, right? Third and fourth floors that kind of span over between the two sections.
That's right. And the top of that is the top of the lab bar or the roof elevation, the top of that structural steel that's already set. That is the top of the building.
Pretty unique building, John.
Very unique. Piece of art.
Yes. Yes. So, and when did you break ground, John?
We broke ground in June. Just about 8 months ago.
Yeah.
7, 8 months ago.
So you look just almost about halfway with the structure. Maybe with the foundation, you're in pretty good shape with the concrete.
Yeah, we're going to set some more steel here. We'll be setting steel through the winter. So hopefully have all the steel set by, I don't know, end of February, early March.
Yeah. So John, most days, at least a couple of cranes moving on.
Oh, yeah.
We'll show further in the videos the two wings that are behind those two sections over there.
You got 3 cranes right now.
Yeah. More or less setting steel, setting rebar,
and they'll be here to set the structural steel in the next couple of months, next few weeks. It all comes in what they call derricks and phases.
Yep.
So we'll start setting some more steel. Well, tomorrow we're going to set the south tower steel that will look just like the north tower structural steel. And then in about 2 weeks we'll follow with what they call derricks 3 and 4, which is steel for down lower there.
The derricks usually mean like a particular floor level section of the building.
Section of the building. There's like, on here I think we have like 20 derricks of steel.
So they break it up so they can keep track of.
And for fabrication and tracking.
Yeah. Well, thanks, John. Let's take a walk. Go ahead a little bit.
This is the steel that's going inside the cores. Inside the south core. It'll be set tomorrow.
Right. So it's basically the structure inside the concrete. That's what all the shear pins are that you were talking about that hold the concrete into the steel. Yep. It's not everyday construction that you see, the steel that's cast in like that.
You can see the embeds that will be exposed in the concrete when they pull off the forms. See
right.
The embed plate
I do.
On top of it.
Yep.
And then
those
the
are
base plate is right down there.
The plates, John's talking about the embeds or the plates that stick back out so they can make connections to later on.
Yeah, then they'll make the structural steel connections to those embeds.
Right.
For the lab bar steel.
Site that you don't get to see too much, right? This is the footing for the retaining wall.
That's right.
In the front, that's the actual corner of the building on what you call the core section.
Core tower. That's not the corner of the building.
Yeah.
The corner of the building is right there where they're building up that.
Where the last column is they're building there with the reinforcing.
Where the reinforcing.
I can see that where it's turning the corner.
This is just a retaining wall.
Yeah.
In here is where all the utilities are going to be placed. Or come in through the building.
There's your permapipe steam piping. I see that, yeah.
This is where the switches and the transformers, the transformers are going to sit right here. The switches are going to sit right here for the main power, for the 13.8 power that's coming into the building.
So that's actually right outside of the corner that you were just talking about.
And that's the corner of the building right there. So this is also the loading dock area is a little bit to the west there.
Yeah, and there's the south wing that we were
There's
talking
the
about a
south
little
wing
bit.
going down that way.
Yeah. The south has one story, John, or
1 story in the wing.
yeah. So John, this is the corner you were just telling me about. We can see the reinforcing. This is all cast in place, concrete, reinforced concrete, and that's actually the turn of the building and the foundation.
Yep. And the wing goes right down there to the west.
Yeah.
And that's the core that's inside
Yep.
the building. Now we'll rise up another 60
So the
feet.
elevators are in there, John.
Elevators
Stairways
in there.
are in there.
All your shafts for the mechanicals.
Mechanicals
are in
going
there.
on it. Yeah.
There's a couple electrical rooms inside there, and there's stairs going
Yeah.
inside there.
Yeah. And they actually support the 3rd and 4th floor that span between
Yes.
the south and north wings.
This is the south wing of the building. This is where ACL is going to be,
Mm-hmm.
and specialty lab. And this has all these grade beams, and for vibration and
Yep.
to reduce vibration on the slab. And just to the west over there, we'll walk down there, are the caissons that further tighten up the building
Yep.
for vibration.
Yeah. So
Over here is the basement of the lab barn, and they got all the utilities in there. You can see, and they're putting in this upgrade, and then they'll be putting down they want to get the slab on grade for it in about 2 weeks, 2 or 3 weeks.
well, we're having this great weather for December 15th, almost 50 degrees. Yeah, a little different perspective looking back up towards the front right now, back at that corner again. Nice. So the difference, John, in the grade beams, normally it's just slab on grade and it's not segmented like that or broken up like that to provide, more support for the slab, where it's usually supported just on the dirt.
Reduce vibration for the lab equipment to stabilize the building. Again, this is going to be single story here.
We're in the south section, right? Yeah.
South section. We'll take a walk if you want. We'll go through here.
I'll turn it off for a minute.
Get another good view of the
North Tower. Actually, the finish on the walls looks pretty high end there. It looks pretty good. I don't see too much cracking or honeycombing at all. Very nice. They use what they call gang forms, John, more or less.
Grabbed on the ground, they swing them up into place.
Pull them up with the crane.
They had to have these so they could pull the forms out, so they could set the steel. And now, if we could get up there, you could see the guys putting in the rebar for the
next placement. And those forms, when they talk gang forms, they just slide up a little bit for the next placement right in there.
They'll suck them in, and then pour. Once they set the rebar, suck the forms in, and then they'll place the concrete, and then they'll lift them up.
Kind of like the classic high-rise when they used to do the inner-city high-rises into gang forms.
These are all the penetrations for the utilities that go into the core and rise up in the shafts that are in the core to the mechanical space that's on the lab bar on the top floor. Get a nice view of the north wing here.
Right, so we saw the south was completed earlier. This is in a little earlier stages of all the grade beams, the sectional grade beams through here, John?
Yep. Same thing, grade beams for vibration of equipment. This is the AMIC wing. They'll have specialty lab equipment in it. And again, you can see how it really isn't that wide, but this will be a single story. It's very similar to the south wing.
Yep. Nice, coming along nice.
Nice view of the road.
So, John, we're on the core section, somewhere's around the 2nd to 3rd floor.
That's right.
With a shot down on the rebar. As you were telling me earlier, they keep the panel away so that they can do all of the work, get in there.
See a guy down there, they're setting rebar.
Yeah.
The bar. Now they're going to suck in the form.
Now pull it in. This is the gang form.
And they're going to be pouring these walls, this lift, probably maybe Thursday or Friday.
Nice. So, John, take me over to the corner here. You get a pretty nice view of the wings we just were looking at. The north wing. Yeah.
The north wing. Good view of the north wing with all the grade beams. And you can't really see
So the north wings doesn't have the pilings like on the south wing?
No. Well, there are some pilings. You can see in the very end there are some pilings down there.
Yeah.
But that is where the microscope's going to be over in the south wing where most of the caissons are.
So where they're really trying to keep the vibration down to a minimum?
Yeah.
So that's pretty much the big theme on this innovative partnership building is the lack of vibration that they're trying to create, or just from general ground vibration that you don't even realize is there.
See all those caissons, the round concrete tubes over there, they go down about 80 feet sunk into bedrock.
Okay, they drive them all the way to refusal to bedrock.
A couple up here you can see, and that's for the structural steel supports for the steel that's going across here.
Yeah.
They'll have V castings coming off those.
So is that a walkway out there, John? Out there? Is that
that'll be a walkway eventually, but you'll also see these V supports for the rest of for the lab bar, to support the lab bar in between the two cores.
Right. So when you look, as we were looking at that picture, this is kind of hanging between these two areas, and that's the one support that's going to kind of grab it in the overhang.
The lab bar overhangs some of the building.
So not your everyday building, John.
No, it's different. It's like a powerhouse construction. All the bars, big bar, 8s, 11s, big. A lot of see the rebars, the epoxy bar.
Yeah.
Goes in certain areas around
Water.
No, electrical circuits. You can get electrical circuit going through rebar that impacts some of the specialty equipment.
Yeah.
They use a lot of epoxy bar.
Yeah.
It'll be all epoxy, I think, from west. Most of the south wing has epoxy bar.
How many men, John, are you running on the average on a day?
Right now there's about 75 guys.
And
we're short of iron workers. We need more iron workers to set the rebar. We had some delays in the beginning of the job, and now everything's breaking open for the iron workers to tie steel. So we need more iron workers to tie the rebar so we can make the placements on the grade beams and on the slab on grade.
So your completion date, John, is next year?
Well, core and shell is about January, 14th of 2017. And valve core and shell is a specialty lab, which is another probably 6-9 months to get the specialty lab, get all the equipment in, get them all connected, and get them up in operation. So that's around say September of 2017.
Big difference between finishing the outside shell and finishing the inside, especially with all the high-tech equipment.
Definitely.